that's okay. Okay, so hi everybody. Thank you for joining me. So today we're here to discuss how we can support you in embedding C.A.D into your primary schemes of work. So part of the focus today is understanding what C.A.D is, understanding about what softwares you are compatible within your school environment, and actually how you can interweave C.A.D into your current projects. So C.A.D stands for Computer Aided Design. The opportunities are there for students to draw and create designs. They can be 2D, they can be 3D, they can be early initial ideas, or they can be final concepts as well. Okay, when you look back at when you start looking at the National Curriculum Framework, and you can see the design element of it, okay, using C.A.D really ticks and covers a lot of the areas in terms of like the generating ideas, developing, modeling, communicating that ideas, the cross-sectional exploded diagrams. And it can be really daunting when you think of that and you're not experienced with design and technology, but it is a lot easier to use than you actually would think. So an example here on the right is the cross-section drawing. So you can see a 2D design. So you can see here what they've designed it on C.A.D 3D and then actual cross-section drawing. This is something that, you know, we would hope that you are delivering certainly in Key Stage 2. What I was just saying before was that it is obviously compulsory as part of the National Curriculum Framework for Key Stage 2. It isn't for Key Stage 1, but I would highly recommend that you introduce using computer-aided design as early as possible. So if you can implement it and start to give students the opportunity to practice on design software at Key Stage 1, that will really strengthen then the outcomes as you progress into Key Stage 2 and as they transition into secondary school and access the Key Stage 3 curriculum, and if they choose Key Stage 4 and up. So one of the things that I want to just mention to you is that software these days doesn't need to be expensive. The two software design software that I want to talk you through during this session, one of them is a cost but very low. The other is free until you get to Key Stage 4. Second of all, they don't take up a lot of hours in terms of training. They have a lot of tutorials. It's very self-explanatory on there, and you know, even just with an hour or 2 hours of your own practice, you can really grasp it easily. The other point that I would like to make is computer-aided design does not need to be a stand-alone unit at all. I would absolutely recommend that you interweave it into your existing projects, and I'll show you some examples through this session later on. Okay, so one of the things that I think is really great is that, you know, obviously in terms of design, the design concept, you know, we all, you know, have the opportunity to do designs on paper, but also using C.A.D gives the students opportunity to do it digitally. And also it's really great opportunity there for students to let students have a discussion as well. So just put on that second bullet point, actually, you know, there's always positives and negatives to everything. And it's really great opportunity actually in primary, to start letting students have a conversation about what are the advantages of using computer-aided design, what are the disadvantages, okay? And it really helps them to make informed decisions. So for example, in terms of advantages with using computer-aided design, you know, you can keep going back and you can make edits to it without having to start again. You can send it electronically. You can send it to a machine, so it could be if you had a laser cutter or you had a 3D printer, and a line cutter. You can have all different sorts of other machinery. There's so many advantages, but then there's disadvantages as well. So it's really great where actually students can articulate that in terms of them making informed decisions. Okay. This is just an example. Again, you have seen this previously when we've had meetings, but just in terms of looking at a long-term plan, it's one of those things where we've actually seen, you know, when you look at your long-term plan, are you incorporating opportunities for computer-aided design? Okay, it might be the long-term plan is very you know, simple. It doesn't tell the full picture. So actually looking at your schemes of work to see actually if you cover it would be really useful starting point. So for example here, if you can see where my cursor is, the graffiti cushion, which they do in for project 4, is yes, the outcome is that, well, the whole process, they learn about how to incorporate decorative techniques, but they'll also include an opportunity for C.A.D there. So within textiles, the students are building up their prior learning from the puppets, the bunting, so they'll learn about applique, different stitch decorations, they'll be able to join, they can do templates. So then when they get to the 4th project, they'll have incorporated and secured that knowledge and bring it into this 4th project. But actually they can use design software to design patterns, okay? And that's what we want them to do. We want them to be creative and innovative and be free. So they could actually design something and apply it to a heat transfer and iron it onto the fabric before they then sew the front and the back together and turn it through and pad it. So actually, where can you start looking at your projects and interweave a bit of C.A.D within there, okay? It might be here as well, you start looking at some of the other projects. Could you actually, if you're wanting to try and incorporate it into Key Stage 1, it could be that you get them simply to access, the design software, and they actually just draw a triangle, okay? So actually, they're starting to do the templates. So you could introduce it really easily like that, and that could be just, a 1-hour session, and they could screenshot it and print it out so it shows that progression through the years. Now, if you look over here as well, you can see here that one of the other projects for the 3rd project is to do with biscuit packaging. So we're talking about shell structures, but actually they'll design the template, the net, using design software. So they'll learn about C.A.D. They might even look up a little bit about tessellation. They'll do the measuring, so you get your maths in there, okay? But you can also, with design software, which you'll be able to see on the clips, you can actually, some software, you can actually test the outcomes before you actually make it as well, in terms of its structure, if it's going to be tensile or not. You can also apply the aesthetics to it, so you can get the graphics in there. So, and then you can see here, even with the food project, you're thinking, how can I actually incorporate C.A.D and interweave it into the food project? So if you think about some of the packaging and the outcomes, again, as another example, it could be a pizza stand. So they might design it on C.A.D, and if you're fortunate enough to have access to CAM, so computer aided manufacture, or you've got a relationship with your local secondary school, which I'll come on to again in a minute, there might be opportunities where, yes, they can design it on the computer, but they also might be able to use and access a 3D printer. So it's just looking and revising and always sort of refreshing and thinking, how can I actually start to include elements and opportunities for C.A.D in your existing projects? Again, they don't need to be separate. Have we got any questions so far?
No, it all sounds fab.
Yeah, okay. So I've already touched upon CAM. So if you haven't heard of this before, so you've got C.A.D where you design it, and then CAM is the outcome. So again, you can see here is a 3D printer. Now you can access these, and I appreciate primary and secondary have a lot of the equipment, and primaries might not necessarily have the same resources, but you can access and you can purchase 3D printers, for around £300. I'm not sure, obviously, in terms of some of the tools available on them in terms of its quality, but I have seen some of them really effective for what you want to achieve at primary level. Okay. And also you've got, your laser cutters as well. So one of the things that I would recommend, again, if you might already do this in your setting, but it'd be great to form a relationship with your local secondary school, okay? Because it'd be good to find out before you make a decision on which software to use, okay? Or if you're already using one, you might be reevaluating, actually, you might want to change. Because if your main secondary school, which your students go to, all use, for example, TechSoft, then it makes a lot of sense to actually you choose that at primary, because when they transition into Key Stage 3, they're already at an advantage with that software because they're already familiar with it. Okay, so their progression will be significant. So that's one. And then the second point is, if you haven't got access to some of the computer-aided manufacture equipment, then it might be that you end up working with some projects and you can actually use or tap into some of the teachers' expertise, but also access to their machinery. So there's a couple of benefits, real benefits for that as well. And also they also get and have an advantage to that because they get to meet some of the students ahead of them joining as well and actually be familiar with what they're coming in with so they can adapt some of their projects to smooth that transition. So just a couple of examples of some of the outcomes that you can do from obviously from designing as well, and then obviously some of the outcomes from the manufacturing. So you can design logos on software, you can design badges, stencils, cards, fabric templates, like I say, for textiles, nets for packaging. They're just some examples. So what I'm going to come on to now is just options. Okay, so this is lots of different software, design software. Now, I've got 5 clips to share with you. Okay, now each of them lasts 10 minutes. I will be uploading each of those 5 clips directly onto Josie TV Catch Up. Now, what we have is TechSoft have been really generous and have produced and personalised a clip for us. So we've got a beginner's guide to TechSoft for primary, and then we've also got an intermediate one. So if, for example, I know, Stephen, you're quite familiar with TechSoft, you might choose to go to the intermediate and use that for maybe Key Stage 2, Key Stage 3. The same with Tinkercad. So AutoCAD, so Tinkercad is part of AutoCAD, and Ed, who works on behalf of them, has also produced a beginner's guide to Tinkercad, and also he's also produced an intermediate bite-sized clip for you to look at as well. I also asked him, even though this is based on primary, I thought it'd be really useful to then look at how we develop it into Key Stage 4, because we're thinking about the children's progression from Key Stage 1, 2, 3, and if they choose at a Key Stage 4. So Tinkercad and TechSoft, you would say, would finish at Key Stage. Certainly Tinkercad would finish at Key Stage 3. So what they recommend that you use at Key Stage 4 is something called Onshape, if you're familiar with it. So again, there's another 10-minute bite size in terms of just how you navigate on it, what you can actually do. It's really, really useful, okay? So just going back to this, so Tinkercad is absolutely free. It's free for primary, it's free for the intermediate for Key Stage 3, and it only starts to become a cost when you start accessing Onshape at Key Stage 4. In terms of TechSoft, okay, primary TechSoft, it is a small charge, so you would have to get in touch with them, but they offer either a 2-week or a month access to see, and you can access it yourself to see if it's something that you want to commit to. It isn't extortionate at all, and I'm not sure if they might do some deals if it's more than one school joining. Okay, but Tinkercad is absolutely free, which is great. The other advantages to these, which I thought was really important to look at, is actually compatibility, because that's absolutely crucial before you start to introduce anything into your schemes of work if you haven't already got them. So in terms of Tinkercad, it's absolutely great because they're compatible with PCs, Macs, iPads, Chromebooks, everything that you'd have in school. In terms of TechSoft, it's it's compatible with PCs. Okay, so just about you understanding what you currently have in your setting, how many you have of them as well, if they're up to date, and then seeing which one you would feel would work for you. Again, in terms of Onshape, it's similar to Tinkercad. Well, it's the same as Tinkercad. You can access them. You don't have to download any software. You can just access them on these devices. Okay, so what I've got here are the 5 clips. I'm just going to show you the first one, and then what I'll do is I'll stop that, and there's opportunity for some questions and Q&A with me. And then, like I said at the beginning, you can access all 5 bite sizes on the catch-up. Okay, so Just going to share my screen.
Hello, good afternoon. My name's Ed Charlwood. Joe's asked me to make a brief introductory video for you regarding Tinkercad. This is really an absolute basics. If you've kind of used CAD before, you've got a bit more of an understanding of what CAD is, then you might want to skip to the second video. For starters, I just want to talk you through what CAD is. CAD stands for Computer Aided Design. It's simply just using computers to help you design things. So like you might use PowerPoint to design a presentation, this form of CAD we're going to do help us design parts and products, but also electronic parts as well. In the Key Stage 3 National Curriculum and the Key Stage 2 National Curriculum, Tinkercad is going to help you really cover lots of these areas, particularly developing and communicating design ideas, using, amongst other things, 3D and mathematical modelling and computer-based tools. This is going to fit really nicely when you're trying to do some of those things. But not only that, I think it's a really convincing tool to allow you to have a kind of really creative outlet. And much like some of the other coding tools and gamified tools, it really is open-ended, and you'll be really surprised with how your students get on with it. We're going to be using a program called Tinkercad, which is from a company called Autodesk, and it's entirely free for you to use. I'm going to suggest in the first instance that you sign in and try it yourselves before we get into the complexities of getting it to work for your students. For your students who are under 13, you will need to set them up an account. It's not a difficult thing to do. We'll address that a little bit later on. All you need to do is go to tinkercad.com, click on sign up. And once you've signed up, you can go to Educators Start Here. If you've got a single sign-on, you can sign on with your single sign-on. This is me, edcharlwood@gmail.com. And this is the screen you're faced with. Your student screen will be slightly different. This gives us an overview. And I'm just going to jump in and show you 2 or 3 different features of what you can do in Tinkercad. And we're going to look at 3D shapes. We're going to look at doing some electronics. We're going to look at how we can learn how to use it and also find some projects. So I'm going to start off and dive right in. I'm going to click on designs and I'm going to start a new design. I'm going to start by designing a 3D circuit. 3D part. The screen will open up like this, and depending on how you're using this, the navigation is slightly different. So I'm currently right-clicking my mouse to navigate around the work plane. I can scroll in and scroll out using the scroller, and I can pan left and right by holding down the scroller. I can also see up in the top left-hand corner here, I've got what's called the view cube. You can see the view cube mirrors what I'm doing with my mouse. That's a really good way of exploring moving from 2 dimensions to 3 dimensions and thinking about different views. Those of your students who play things like Minecraft will be really adept at this. Others who haven't might find it a little bit trickier. The way we design things in Tinkercad is to drag things out for these shapes they call the primitive shapes. And we design by resizing them and combining them together. So for example, I'm just going to take the simple box, drag it onto the work plane. The box is on there, a couple of things pop up. So first of all, I've got some white cubes. I can just click and move those white cubes to make my cube bigger and smaller. Drag them left and right, up and down. Or I can type dimensions into them. So if I want it to be an exact size, put them in. It's a really good way of maybe thinking about volumes in maths. Really nice way of exploring those and seeing what happens if you were to double up. So now I'm just going to use a keyboard shortcut of Control and C, Control V, just to duplicate them. It's a really quick way just to start to recreate our shapes and again move them around. Now you'll notice when I'm designing, I can intersect these blocks together so I can cross them over each other. So unlike other CAD programs, I can just move things around to get them wherever I want them. The more shapes I pull in, the more I can just put them wherever I want them to be. So in that respect, I can create shapes really, really quickly. The other thing I can do with my shapes, I can change what they are. So at the moment, it's a solid shape, but I can also change it to be a hole. That will then be the inverse. And what will happen now, if I select all my shapes by drawing a lasso around them, going up to this tool here, which is called Group, I group them together, it will take away that shape of those two. You can see how I've done some removal. So a little bit of maths again, a bit of subtraction in terms of my shapes, taking one thing away from the other. And I can go back and undo those if I want to and play around with that formatting. Down the side, we've got a whole different palette of shapes. Choose whatever you want. You can also search for other shapes, search things you might want, like a wheel. Find in here all the different designs that already exist if you wanted to build something like a chariot or a cart. I'd really encourage you to go and play, have a look around, see how you get on with it, but playing in here is a really, really good thing to do. The second thing I want to show you, Tinkercad, is what's called Tinkercad circuits. The same approach again, I'm going to say new, let's say circuit. In a Tinkercad circuit, you'll see the screen looks kind of the same. Instead of being a 3-dimensional workspace, we're a 2-dimensional workspace. What I can do in here is just drop different parts in. A resistor, LED, push button, a battery, and then I can see what happens when I wire them all up. In this case, I'm going to wire up my circuit, see what happens. What's really nice in here is I can simulate my circuit. When I press the button, you can see the LED turns on. And I change the value of the resistor from 1,000 ohms, say 20 ohms. You will see the LED brighter, but I'm also getting a warning message, so the resistance isn't high enough. It's a really nice way to explore circuits and delete all these parts quickly. It's also a really nice way, if you get onto it, for microbits. I can go in here and use microbits and code my microbit in here as well if I want to, and simulate my microbit working as well. One more thing I wanted to show you was the gallery of objects. Maybe you're doing something in particular in one of your lessons and you wanted to have a play around with finding something that was right for you. In this case, I'm going to use a skittle alley. There's already a whole series of designs that have been made. What's really nice with your skittle alley is you can use this tool, which is the apple falling. It puts you into what's called the sim lab. This has only been released a few days ago. When I go into the sim lab, it will add physics and forces and simulation into my what I can do is throw things at my skittles, if I can make them fall over. And you can see my skittles falling down and falling off. So it's a really fun way to explore and experiment. Loads of new examples are coming up. The last thing I wanted to show you is something that's built into Tinkercad. It's really fantastic. Is the resource center. And in here it's got a really nice set of things, lesson plans, tricks and tips, but the learning center for me is fantastic. It's a really nice way to set students' work and get them going. You'll be really surprised with who picks it up and who doesn't and who struggles a little bit. And because you've got this resource center, it will take you through and allow them to learn at their own speed. The instructions look like this. And they go through and they've got a really nice graphical explanation of what's going on. You're going to see you get an instruction panel down the side with some questions of what to do, and what you have to do is literally follow along. Once you've followed along and done what it's asked, it's jumping around, done what it's asked, okay, click on the step for next, and it's going to give you a nice little explosion and tell you you've done it properly, and then it will take you to the next one. Okay, so you're going to self-pace and take your way through resource by resource, tutorial by tutorial. In the second video I'm going to share with Joe, we're going to look at how we can set yourself up as a class, look at a few more of the learning pathways that you could use, look at how if you're using an iPad you can get an augmented reality view. But hopefully this is just giving you a lot of flavour of what you can do with Tinkercad. Not only is it a really good creative tool, but it's also going to allow you to meet some of those national curriculum requirements. I'll share my details with Joe in case if you've got any questions or want to help getting started. But I hope you enjoy using Kempston.
Brilliant. Okay, I'm just going to stop sharing, everybody, and I'm going to finish recording. And
hello, good afternoon.
Sugar. There we go. I'm just going to come back to you, and we have an opportunity for some Q&A. So just bear with me. Okay.